In this course, we will learn, of course, about pens. And the structure of this course is going to be first start with the finite difference methods, the usual way of solving PDEs or partial differential equations to basically model a system. And later, what we are going to do is to actually go to pens. We will start with a little bit hard part of pens, which is well, basically solving them using PyTorch. A little bit more programming needed in here. And after that, the course will become much easier as we are going to use a DeepXDE library to solve pens. It will make our life much easier, and actually we can model uh, complex systems in a very short time. So finite difference methods are usually used for solving partial differential equations. Of course, it's what we call usually a numerical solution. A numerical is just a way to solve equations, not, of course, analytical, not using well, math laws by our hand. What we try to use is numerical solutions that give us a more flexibility in solving these partial differential equations. So the first part of this course, we are going to first understand how to solve partial differential equations numerically, the old way of doing it, let's say, using finite difference method. And to get this, to do this, we will just take the heat equation that describes how the heat or the temperature basically the heat propagates and change the temperature into in our in a system. So we will have the rod and we will have two heat sources, and we will see how this rod will increase in temperature. So it's quite interesting, and we will see the how we will code it all by ourselves from zero using of course Python. Now after that we will step our game a little bit. The heat equation is kind of the fusion equation, and it is more or less always like it's much more robust as it has this diffusion well factor that kind of will make it kind of converge most of the time or many times much easier than the convection equation or the convection that doesn't have convection term like du over dy. So we have this we will well now we want to step it a little bit. We have this diffusion term and we have this convection term, and in which we will try to solve an equation that has both, which is the Berger's equations. And these Berger's equations are, well, more complicated than 1D heat equation. We are going to solve it using also a finite difference method. We'll go step by step and we will this time solve these two beautiful equations and get hopefully the answer. Now we become familiar with finite difference methods and how to solve the problems with it. We step it now. Well, now we have to work with pens, but of course we have to work kind of cautiously. So we will start by solving 1D Berger's equations. Because why Berger's? Well, first 1D is, of course, it's easier, and 1D Berger's has many things we need to learn. The first one is, as you can see, this the second derivative of u over dx, first derivative of u over dx, and derivative of u over time, which is interesting to see how the solution will progress also in time. So this is going to be actually our solution, and this is going to be solved using pens. This is going to be the first pens problem we solve. Now after that, what we need to do is how about go to solve a 2D problem. The first pins problem we solved is a 1D problem, and now we need to go and solve a 2D problem. To do that, we took the 2D heat equation and we, well, write our code to solve it with, of course, pens. Now, solving with PyTorch is, of course, important, and most likely, if you are most likely if you want to write your own software, it's better to write with Python. You have a control on everything, more or less, much more higher control than if you use a library. However, there are libraries that actually make PENS solutions easier. For example, DeepXDE is one of them, and this library, we are going to use it to first solve a 1D heat equation. Just to know the library, how can we achieve a solution using this library? And we get a little bit familiar, and we will see how our coding will become easier, and our solution will we can get to a solution faster compared with writing our torch problem. Now we get familiar and we get stronger with pens. Why don't we solve Navier-Stokes equations? I'm sure many of you like Navier-Stokes equations, which is equations that is used to model fluid dynamics. We take these equations, which are, in our case, what we are going to solve is a steady state Navier-Stokes equations. However, in these equations I'm putting on this slide, we have time. Just you put it 0 because du over dt is going to be 0 in our case. And as you can see, there are, or as you know, there are many forms of Navier-Stokes equations. This one, we are going to solve two momentum equations, one in u direction, one is in the v direction, in the horizontal axis and the vertical axis, and the third one is the continuity equation, which is this one. Of course, Navier-Stokes equations might have other equations, for example, the energy equation, and Navier-Stokes, it can even expand through other things like reactions and even electrohydrodynamics. It can get quite complicated. However, let's take this simple 2D steady state equation, and or we model it into a steady state using these equations and solve a 2D problem. And with that, hopefully we get already familiar enough with solving equations using pens, and by that our course is over, and hopefully it will be a very important step and try to reduce your time learning pens or physics informed neural network.